Hello, welcome to Math 1324. This is Chapter 10, Section 5, Example 1. In this example, we want to convert the following exponential expressions to logarithmic form. Now, all of these are just true statements, and we want to convert these into a logarithmic form. To do so, we have to understand what a logarithm is. Basically, if we have something like a to the y equals x, and we want to get the exponent by itself, we would say y equals log base a of x. Now, a logarithm is just a different way of writing an exponential. In fact, it specifically is written so that the exponential is, the exponent is outside of the exponential. It's out here by itself. Also notice that you have a base of a here, and here you also have a base of a. They're the same base. Now, this is written as a subscript. That's very important. Okay, so it's a subscript with a base of a, and then this right here is called the argument. Okay. Now, specifically for logarithms, the argument must be greater than 0. That's going to give you your domain. The range is all real numbers. And of course, for this one, because x is the only thing in the argument, that gives us 0 to infinity. And we do get vertical asymptotes at x equals 0. In other words, wherever the argument is equal to 0. And that's pretty much all you need to know for now. But here, we're just practicing this, starting here, going to here. So let's do that for each one of these. Starting with a, we have 5 squared equals 25. Now, notice that the exponent here is 2. That means that this 2 is equal to a logarithm. Well, what's the base of this logarithm? Well, the base is the base of the exponential. It's 5. And what have we not used yet? We haven't used this 25, so that goes here. So 2 equals log base 5 of 25. And that's it. That's all there is to it. Let's look at B. 1/4 to the third power equals 1 over 64. The exponent is there, which means that the exponent is equal to a logarithm. Now, the base of the logarithm is the base of the exponential, so it would be 1/4 as the base, and then the argument of the exponential is what's left over, which is 1 over 64. And that's all. C, 2 to the negative 4 equals 1 over 16. The exponent here is negative 4. So negative 4 is equal to a logarithm with a base that is the base of the exponential, which is 2, written as a subscript, of 1 over 16. That's pretty much it. Letter D, 8 over 125, all to the negative 2/3, is equal to 5/2. Yeah, this entire thing is wrong. Instead of 5/2, make that 25/4. There we go. That's better. Anyway, now that that's right, the exponent here is negative 2/3. So we have negative 2/3 is equal to a logarithm, and the base of the logarithm is from the exponent, so we get 8 over 125. Then the argument will be what's left over. Let's move on. We have 4 cubed equals 64. The exponent is 3, is equal to a log with a base of 4 of 64. And there you go. That's pretty much it. I know it's kind of crazy, but converting from exponential form to logarithmic form really is not that hard, especially once you start seeing this pattern. Alrighty, well, I'll see you in the next video. Have fun.